How do you determine the name of a chemical compound? Well, first, there are three different types of chemical compounds. The first type is between a metal and a non-metal. The way we name type 1 chemical compounds is by using the metal followed by the non-metal and adding the suffix "ide" at the end of the non-metal. Let's look at a couple of examples. Firstly, for something like NaCl, we would simply look at the metal and the non-metal, in this case sodium and chlorine, and add the suffix "ide" to the non-metal, giving us sodium chloride. For CaBr2, we have calcium and bromine, so we must add the suffix "ide" to bromine, and we have calcium bromide. For Al2O3, we have aluminum and oxygen, so we must add the suffix "ide" to oxygen to give us aluminum oxide. The second type of chemical compound is between a transition metal and a non-metal. In order to find the name for a type 2 chemical compound, we must follow the following process. We must take the transition metal and add a Roman numeral, which I will explain in a moment, along with the non-metal with the suffix "ide" to give us the name of the compound. For example, for something like CuBr, we have copper and bromine. So how do we find the Roman numeral that we're going to use for the name of this compound? Well, we know that bromine has a -1 charge. And since this compound is neutral, we know that copper must have a +1 charge, meaning that that will be our Roman numeral. And so we have copper 1 bromide. For FeS, we have iron and we have sulfur. And sulfur has a -2 charge because it is in group 6A of the periodic table, meaning that it has 6 valence electrons and needs 2 more to be an octet. This means that if sulfur has a -2 charge, then iron must have a +2 charge, giving us iron 2 sulfide. For a compound such as PbO2, we know that oxygen has a -2 charge, since it is also in group 6A of the periodic table, and needs 2 more valence electrons to be octeted. However, there are 2 oxygens, meaning that there are 2 oxygen atoms that each have a -2 charge, giving us a total of a -4 charge. This means for this compound to be neutral, lead must have a +4 charge, giving us lead 4 oxide. Type 3 compounds are between a non-metal and another non-metal. The way that we name type 3 chemical compounds are by using prefixes in front of the non-metals. The prefixes are shown here. For something like CO2, we have 1 carbon and 2 oxygen, meaning that we would need to use the prefix di in front of oxygen. And we get carbon dioxide. Note that we do not have to use the prefix mono for the first non-metal in a diatomic compound. So we do not need to say monocarbon dioxide. However, for the second nonmetal in the compound, we would need to use mono. So CO would be carbon monoxide. For a compound SF6, we have 1 sulfur and 6 fluorine. Since sulfur is the first nonmetal in this diatomic compound, we do not need to use mono. For fluorine, we'll need to use the prefix hexa, since we have 6 fluorines in this compound. And so we have sulfur hexafluoride. For a compound such as N2O4, we have 2 nitrogen and 4 oxygen, meaning that we would need to use the di prefix for nitrogen and the tetra prefix for oxygen. And so we have dinitrogen tetroxide. Thanks for watching. Like and subscribe.